Really nice being here, and thanks for the opportunity. So in the next 20 minutes, we're going to see what are the key characteristics of the applications that are built to be deployed in the cloud, and especially the cloud-native applications. Hopefully, I think it's the first only technical presentation, so everybody will be able to follow. I won't deep dive into many technical terms. I'm Konstantinos Zacharakis. I'm VP of Engineering in Workable, and throughout my 20 also years of career, I have the opportunity to be exposed in multiple and various architectures, both in infrastructure and in application layers. And I'm quite old enough to recall what it was like to deliver an application on a physical server like that, where you had to work usually in a dark and cold room, providing manual scripts, and usually with a downtime. Are there any others that have experienced that before? Only a few heads. Yeah, thankfully, at our days, releasing an application looks like that from the comfort of our home. And in many cases, many teams have also achieved to deploy applications fully automated through proper pipelines. So it's been a long journey to reach that point, and I think it will be interesting to see how the evolution of the computing infrastructure evolved over the decades. So starting from the pre-epoch years of mainframes and mini computers, to the 80s and 90s with the workstation PCs and servers, to the 2000s where the VM servers set the base for the cloud as we know it. In the two last decades, from the infrastructure as a service providers to platform as a service and containers, microservices and serverless infrastructure. And I think it's also interesting to see how the software architecture evolved and adapted these changes over the years. So I think we can identify three main categories here, starting from the monolith, first eras applications, to the multi-layer applications, to microservices. And I think there's also an interesting Italian food analogy to that three categories. So starting from the spaghetti infrastructure, where everything is pretty much mixed together, making it difficult to separate the components, to the lasagna, where we have the distinct components and layers, however, they're still coupled, connected, and interconnected, to the ravioli architecture, where each component is self-contained and independent, allowing easier maintenance and scaling. However, as George this morning mentioned on his 5-rule framework, the software design is not only adapted based on the infrastructure, there are also other factors that affect and define this evolution. So the Conway's law is one of them, so we should not neglect that our organization and the team that we structure the teams is also a factor that affects of how we define our system as our architecture. So Workable is a software as a service company, as Michalis mentioned, and it was founded almost 10 years ago in the peak of the cloud era. However, we also started with a monolithic approach of the first generation, since we were a pretty small team at that time, and we started revisiting our architecture down the road all this decade. So we started building some satellite services. On the third generation, we started building beyond the monolith with more microservices and starting employing event sourcing and design system techniques. And on the fifth generations, we completely rethinking the monoliths, starting to deploy also micro frontends on the UI. And however, from the very first eras, we were lucky enough to have employed some techniques that allow us to transition, to help us transition through three changes on the infrastructure. So we first built, when we were on the monolithic approach, the infrastructure was based on the Heroku, a platform as a service provider, and we were able to move to the Amazon services and to Google Cloud. And these changes were able to become without. Can I have some water? Sorry. Sorry for that. So we're able to adapt to those changes without changing, without actually having to stop the feature development from our teams, as we had employed cloud-native techniques from the very first ages. So let's see what cloud-native is anyway. The term has appeared almost a decade ago. However, it's still some ambiguity about its exact meaning. There is actually a foundation, the Cloud Native Computing Foundation, which currently operates under the Linux Foundation, which since 2018 had provided an official, a formal definition. So Cloud Native Computing, as it says, uses an open source software stack to deploy applications as microservices, packaging each part into its own container, and dynamically orchestrating those containers to optimize resource utilization. And these techniques enable loosely coupled systems that are resilient, manageable, and observable, combined with robust automation, which allow engineers to make high-impact changes frequently and predictable with minimum toil. A lot of buzzwords on this definition, but if we were to choose 4 of them, which are the main pillars of the cloud-native paradigm, would be microservices, containers, orchestration, and automation. And I'm pretty confident that most of you are quite familiar with these terms. Actually, microservice and container in particular are trending to become the norms in the modern software development. And at no surprise, they're the key components of the cloud architecture. But to gain a better understanding of how these components, these pillars interconnect between, I think it would be helpful if we were visualizing them as a pyramid. So in the base of the pyramid, we have all the cloud infrastructure, the providers like Google, Amazon, Azure, and so on that provide the base of the setup. On the second layer, we have the orchestration frameworks. I think in our days, Kubernetes is the dominant player on this layer and is supported by all providers. On the third layer, we have the containers, which is a technique which is able to package and isolate applications and their dependencies. Again, I think that Docker has also become an industry standard on this area. On the fourth layer, we have the microservices, the applications we've built. And on the top of the pyramid, which is also one of the most important factors of this technique, is automation, which enables the efficient and consistent management of this entire stack, including practices such as DevOps and infrastructure as a code. So before diving into the principles of its pillars we saw, I think it's first critical to understand what are the challenges the technology is trying to address in a software company like software, or to a great extent to all companies. So, of course, there are a lot of challenges in a business. However, I will highlight 4. The first and most important, the customer growth and retention. So it's about how you will be able to attract customers, how you will be able to retain them. And to do so, you need a strong team and strong infrastructure that will allow you to build a product that the customers will attract them and keep them. The second one is scalability, especially in software as a service as Workable. It's a very important factor as you never know, especially when you start, it's much unlikely to know at what scale you'll start, what the demand will be. So we need an infrastructure that will be able to help you scale efficiently and handle the increased demand. The third is security and compliance. At our days, confidentiality and integrity is an important factor. And in some cases, some business areas also, if you have to comply with legislations, it's also a very important factor to maintain trust with the customers. And last but not least, cost management, as you have to manage and optimize the cost of resources, infrastructure, and the development processes. It's very essential in order to remain competitive and maintain profitability. So as we're going to explore each of these 4 pillars of the cloud native and how cloud native applications can help. Starting with microservices, we will see a set of promises and a set of challenges on each pillar. So the promises that microservices architecture are set that by employing correctly, you will be able to gain faster development and deployment of new feature cycles. You will be able to scale independently the application components, which will increase and enhance the flexibility and resilience. So all this is going to help address customer growth and retention as you will be able to build the product more effectively. Of course, there are some challenges to take into consideration. All this thing comes with an increased complexity, so the team should be able to start thinking with another way, another software paradigm, which is not easy at first. The way that you have to coordinate and communicate between the services is also another factor, another challenge. And in order to ensure the data and the data consistency and integrity is also an important factor. Containers, what they promise. They promise a consistent and secure environment, especially so compared to the traditional techniques where developers were developing, the engineers were developing in a total different environment, and sometimes they were testing in a different environment compared to production. In containers, they provide a consistent and secure environment across development, testing and production, so we have a parity there as a base. With the orchestration, they promise a more efficient resource usage and an isolation of application components. So overall, they can ensure scalability, security, and compliance in terms of the business challenges. The challenge you have to tackle here is that the container images and versioning is another part of the stack, of the software. We have to manage they have a different life cycle we have to tackle. Also, security also is something that we have to take care of. Pretty much a container on the base layer is another operating system that we have to tackle patches and security concerns. And the networking is also another aspect that we have to take care. Orchestration, so how we take all these containers and try to build and automate things. What they promise automate deployments, automate scaling and management of our applications. Compared with the traditional techniques, a proper orchestration framework with good observability can also ensure self-healing systems, so they can, when some systems are not operating as expected, they could replace them without any manual intervention. And the third one, and very important, efficient resource utilization. So when the demand varies, the orchestration service is able to start or stop pods and make more efficient the utilization. So it can enhance our scalability and our cost management in terms of the business challenges. So the technical challenge here is that we have to manage, of course, and maintain the orchestration platform. Ensuring fault tolerance and self-healing is not easy, especially if you are not able, you have to build a good observability platform to to make it happen. Handling updates and rollbacks, and all the availability and disaster recovery also is a critical thing that you have to take into consideration. And last, the automation, which promises the faster deployments and improved collaboration with reduced manual effort between the teams, a better monitoring and observability, infrastructure as a code and version control configuration, and can promise us more streamlined process and optimized costs for our business. The challenges here are that we have to keep up with a very rapidly evolving technology and tool. We also have to balance between automation and manual intervention, and to ensure that any artifact that we build on this automation layer is secure and compliant enough in order to avoid any critical issues. So a lot of challenges. Are there any best practices that someone would recommend? Except of the very famous DevOps that we already discussed and the infrastructure as a go techniques. One other technique, one other framework that helped us a lot from the first ages of Workable is the 12-factor apps. I'm not going to deep dive on that because we are going to run out of time. How, in a nutshell, the 12-factor apps is a framework, is a methodology that was defined by the developers of Heroku about 10 years ago. And as it was mentioned in the original book, the motivation of the team was to raise awareness of the systemic problems they have seen in the modern application development, and especially in their platform, in Heroku platform, which is a platform as a service, as I said. It consists of 12 factors, which cover almost the entire software life cycle. So starting from development, so you can have a check of how to track the code base, how to define dependencies, environment, how to build, to the runtime of how to execute, expose, and dispose and monitor the applications, to lastly how to manage and administer on the runtime. In our case, adapting this methodology at a very early stage enables us to retain a high level of scalability and consistency in our infrastructure, and as I previously showed, enable us to tackle the transition from the three different infrastructure providers. So, as a closing remark, I have chosen to show also another definition of the cloud native, which is from the Joe Beda, which is the founding engineer of the Kubernetes framework. So according to his definition, cloud native is structuring teams, culture, and technology to utilize automation and architectures to manage complexity and unlock velocity. And in the same block entry, actually it mentions that you don't actually have to run in the cloud to be cloud native. So in conclusion, what he's trying to say is that adopting a cloud-native approach involves more than just a technology, just a basket of technology, software frameworks. It's also about how we structure our teams, and we foster a culture of innovation that will leverage automation and architectures that will help us manage the complexity and embrace the business velocity. That's all.
Thank you very much, Vladimir. Okay, we are out of time. Let's go with one question that we see here. Why did you move from Google Cloud to AWS? This is
from Google Cloud?
No. To Google Cloud from AWS, sorry.
Why?
Yeah.
Actually, the period that we switched from Heroku to Amazon was a period where the Kubernetes was not yet it was in a very early stage, so we decided to build our own orchestration service, which soon we understood that it wasn't that easy. And we didn't achieve the same level of automation we had with Heroku. And at the same time, when we decided to go to Kubernetes, the Google Cloud Platform had much better support on that. So that was the main reason. And yeah, the fact that we hadn't moved all the infrastructure in Amazon, which helped us, do that leap again.
Okay, okay. And last one, are microservices a prerequisite to define cloud-native computing?
No. And actually in Workable, the big part of the software is not based on microservices. It's still a monolith. We love our monolith. We don't have, we don't want to break it per se, but we try to find cases and features and flows that when they don't fit with the technology stack, we build them on the technology stack and on an architecture that they fit. So I don't find it essentially. Actually, inside the microservices, you will find many monoliths if you think of it. So it's not that you have to demonize the monolith.
Exactly. Thank you. Thank you very much.